Lesson 411, Bearings in Simple Harmonic Motion. Bearings show direction. For example, 30 degrees north of east, be like this. We have a compass rose, north, south, east, and west. 30 degrees north of east, the way English works, we start at the east and then go north. So we start at the east and go towards the north 30 degrees. So what would 30 degrees south of west look like? Well, we're starting at the west and then we're going to go south. So we start at the west and then we head south. So that'd be 30 degrees south of west. So let's do a problem using bearings. Sailboat leaves a pier and heads due west at 8 knots. A knot is like a mile per hour, but only for sailing, where it's a nautical mile per hour, which is slightly longer, more than a regular mile. After 15 minutes, the sailboat tacks, changing course. All right, so what we could do is we could draw a picture. So we could say, here's the pier. We go this way. Well, how far that way did we go? Well, 15 minutes is 1/4 of an hour. So if distance is rate times time, our rate is 8 knots, and our time is 1/4 of an hour. So that would be 2 miles. Then we change course. So let's put a little compass rose here. And we go 16 degrees west of north. West of north means I start at the north and go 16 degrees towards the west. So it's that angle there between the north heading west. At 10 knots, okay, find the sailboat's bearing and distance from the pier after 12 minutes. Oh, well, how far did we go? Our rate is 10. And our time is 12 minutes. To get that into hours, we could divide it by 60, and that gives you 2 miles. We want to find from the very beginning to the very end. That is the distance we want. The way we're going to do this is we are going to split up all our things. We're going to draw right triangles. So there is a right triangle for the second half. The first half is just a horizontal line. And we are going to tally these up into x's and y's. The first one is just motion in the x. It is just 2 miles towards the left in the x. Since it's going left, I make it negative, and the y is 0. The second part, well, we're going to figure that out. The horizontal, the x distance is up there, and it's the opposite of the 16. So we could figure that out with sine. So we could say sine of 16 is the opposite over the hypotenuse. So x would be 2 times sine of 16. However, it is heading towards the left. Our arrow is going up and to the left. Left is usually negative, so we'll make it negative. The y is the adjacent to the angle, so we could use cosine. We could say cosine of 16 is the adjacent over the hypotenuse. So the y would be 2 times cosine of 16. And that is going up, so it's positive. Now why would we do this? Well, we're going to add these. What it does is it can give us a new triangle. We'll have the first part of the x, which was -2, and then the second part of the x, which was -2, sine 16. Then we have the y, which is just 2 cosine of 16, and we're looking for this hypotenuse. So now that just makes a right triangle, but I have to add the sides to get our totals. So -2 minus 2 times sine of 16. All right, so that is -2.55. And in the y, it is 1.92. So this whole distance is -2.55, or the distance itself is 2.55, and it's going left. And the y is 1.92. Well, how could I find the hypotenuse of that? Right, we could use the Pythagorean theorem. Let's use d for distance. Okay, we're using the Pythagorean theorem. So we'll take a square root. Be square root of 10.1889. Which is 3.19 miles. So our distance is 3.19 miles. What about the direction? Well, we want the direction at the beginning, so that would be the useful one. And we know the opposite side and the adjacent side. So it'd be opposite over adjacent. And I'm going to use the positive 2.55 because the negative just says it's going towards the left. But to do right triangle trigonometry, there's all the sides are positive. So to get your angle, you'll have to do inverse tangent. And I get 37.0 degrees. So we need to describe that. So our answer is 3.19 miles at 37.0 degrees. And let's see, it's measured from the west and heading towards the north. So it would be north of west. Trigonometry can also be used for simple harmonic motion, or SHM. So consider a spring. So we have this spring here, and we have a mass on the end. And it's kind of bouncing up and down, like you pull it down and let it go. So it goes up, so spring pulls it, but then the weight's heavy, and it pulls it back down, and then it's all the way down, and the spring pulls it back up, and it keeps pulling it up. But up there, the weight's heavier and pulls it back down. It keeps going down until it gets all the way stretched out and the spring pulls it back up. And you can see over time, we get a nice sinusoidal curve, or a sine curve. So you could use sine or cosine to model this. A is the amplitude. And the amplitude is the distance between the equilibrium and the highest point, or equilibrium and the lowest point. And the W looking thing is this lowercase Greek letter omega, and it kind of takes the place of B that we had before. You use it to find the period. The period is 2 pi over the omega. Period is the time of one cycle. So that's one up and one down. Frequency is cycles per second, or how many cycles are in every second. And that is just the reciprocal of period. So period and frequency are reciprocals. The dotted blue line is the center line, which is equilibrium. So let's find a model for simple harmonic motion. And our displacement at t0 is 0. What's that tell us? Well, which graph, sine or cosine, goes through 0 at 0? Sine. So this tells us that we're going to use sine. Our amplitude of 4 centimeters tells us A is 4. And a period of 6 seconds. Well, period was 2 pi over omega. So 6 is 2 pi over omega. Multiply both sides by omega and divide by 6. So it looks like omega is 1 pi over 3. So our function, we're going to use sine, so it's y equals a sine omega t. A is 4. Omega is pi over 3. And there's a function to model the situation. Let's go the other way. Here's a model. Let's come up with all the other things. So this would be like y equals a cosine omega t. So omega is both the 6 and the pi. Maximum displacement. That would be the amplitude. And the amplitude here was 4. Find the frequency. Frequency was omega over 2 pi. In this case, omega is 6 pi. So 6 pi divided by 2 pi is 3. Find the value of d when t is 4. So that just means we plug in a 4. All right, so that's 24 pi. So what would be the value of cosine at 24 pi? Well, you can either think of coterminal angles in unit circles or whatever, or use your calculator. The cosine part is 1 times 4 is 4, so our displacement is 4. And lastly, find the least positive value for which d is 0. So we'll make d equal 0. Probably divide by the 4 first, so that you can see we need to just find out when cosine equals 0. We cannot divide by the 6 pi because the 6 pi is inside the cosine. But when does cosine equal 0? Well, if we look at our unit circle here, cosine is x. X is 0 there and there. Well, the top, that would be pi over 2. So our angle is pi over 2. Well, the angle in our function is 6 pi t. So we need to divide pi over 2 by 6 pi to get t. You divide by multiplying by the reciprocal which gives us 1/12. So 1/12 of a second or whatever. It'll be at 0.